Hello everybody. Today we are going to solve this geometry question which was part of Geometry Week in my Facebook and WhatsApp groups. We are going to first unpack the question, understand what information is given to us. Second, we are going to look at the diagram and make sure we are not making any bad assumptions. That happens a lot when you are working on a problem and the diagram is not given to the scale, and you will see that happening here. Third, we are going to write down some of the concepts that are applicable to this particular problem, or at least that we think are applicable to this particular problem. It is always a good practice because geometry has so many different theorems that it makes sense to keep going back to your list to make sure you're not missing anything, especially when you are stuck. We'll talk about a solution strategy after laying down the concepts we think are applicable to this question. What would be our strategy? And finally, we are going to solve this question. So let's get started very quickly. But before we jump in, if you like this video and find it helpful, please do not forget to like the video and subscribe to my channel. If you have any comments, I personally respond to all the comments. Please take a moment to put your comments in the comment box. So let's start looking at stage number 1, unpacking the question. Okay, so in this question, we are given that PQRS is a parallelogram. Point Z divides the line SR into ratio 2:1. And this is very important. And if you look in the diagram, since it is given that the diagram is not to scale, any assumptions we make here could be bad. For example, in the diagram, it looks like SZ is smaller than RZ, which is really not the case. It is actually the other way around because it is given that SZ is to RZ is 2:1. So making that assumption that the ratio is actually reversed will actually get you in trouble. So avoid the bad assumption based on what you're seeing in the diagram, because diagram is not to scale, it is clearly given. So we are going to clearly mark that SZ is greater than ZR or RZ. We are also given that point Z divides SR into the ratio 2:1. So first theorem that we would use here is that the distance between two parallel lines is always the same, no matter which point you take the distance between them. As long as you measure the distance, which is the perpendicular between these two lines, it will always be the same. Secondly, the area of a triangle is half base into height. And finally, the fact that the diagonal of a parallelogram actually bisects it, which basically means that it breaks it into two equal parts or two parts of equal area. So let's get started on how to solve this question as our step number 4. We are given that the area of this quadrilateral, which is PQSZ, is 15. We are also given that these two sides are in the ratio 2:1, but we are not given the measure of these sides, which is fine. We know that if we draw the diagonal QS, it will divide the parallelogram PQRS into two equal parts. We are also going to draw a line perpendicular from Q, and we are going to use the property that the distance between two parallel lines is always the same for triangle QZR as well as the triangle QZS. So this is our strategy. We are going to somehow use this information to finally figure out what the actual answer to the question is. Okay, so this is how my parallelogram looks like at this point. Let's look at these two triangles, triangles SQZ and triangles QZR. What are the bases of these triangles? So base is SZ and ZR, which are in the ratio of 2:1. Height of these triangles is same as the height or the distance between two parallel lines in the parallelogram, which is this one that I created. So height of this, whatever it is equal. So the areas would be half SZ multiplied by H and half ZR multiplied by H. Now we know that SZ and ZR are in the ratio 2:1. Okay, so since SZ is equal to 2 times ZR, I can write the area of SQZ as 2 times ZR multiplied by H divided by 2. What I know is when I add these two areas up, I get the total area of the parallelogram divided by 2. I'm going to just say it P by 2. So we can further simplify this into saying that P by 2 is nothing but 2 times triangle QZR plus triangle QZR, which means half the quadrilateral is 3 times triangle QZR. Let's keep this as is for a second and look at what is quadrilateral PQZS. PQZS can be written as half the parallelogram, which is this area, plus the area of triangle QZS, which I have written here. I already calculated P by 2 to 3 times QZR. So let me write that as is. And I also know that the area of triangle QZS is equal to 2 times QZR. So that is again 2 times QZR, which makes it 5 times QZR. So what I have is the quadrilateral PQZS is 5 times the triangle QZR, which means the area of triangle QZR would be 15 divided by 5 equals 3 square units. So the answer to this question would be B. There are many other ways to set up the equation. However, you will get the same answer of 3 square units for the triangle QZR. My recommendation is you take a pen and paper and try to solve it on your own by setting up the equations the way you want it to. In the end, you would apply these 3 concepts to get to these answers. I hope this was helpful. If you have any comments or something you did not understand, please put it in the comment box. Thank you. Have a great day.